Okay, today we will talk about a normal distribution. When we draw the histogram, then if the histogram is following a shape that looks like a bell curve, then this is called a normal distribution. Some of the examples of the histogram that you see here, like the weight of infant, time taken to complete an assignment, and the height of students, is showing the shape of a bell curve. So if you go like this, so then you will notice that those curves, even though that in different heights or wide, still they have the same kind of form. This one is known as the normal distribution or bell curve. So what do you see in the normal distribution is the a relationship between the data value and the frequency. So in the y-axis, you will have the frequency, and in the x-axis, you will have the data value. Now, the line that kind of divide the bell curve into two equal parts is where the mean is. Where the mean is. The mean. And then it's divided into standard deviation. We will see that in the next. So now, imagine the area under the curve to represent the given data offset, so 100%. This line here being the mean, or mu, then each of those lines will be the one standard deviation. So on the first one, so this line here will be mu plus 1 standard deviation. The other one will be mu or mean plus 2 standard deviation. And the third one will be 3 standard deviation. And when we go on the other side of the curve, then we will have mean minus 1 standard deviation. The other one here is mu minus 2 standard deviation. And the third one is mu minus 3 standard deviation. Now, each of them represent a percentage. So when we are moving from mean to 1 standard deviation, then we are about 34% of the data. We are gathering 34% of the data. And then when we move in the sector between 1 standard deviation to 2 standard deviation in this sector here, then we will have 13.5% of the data collection, 13.5% in both of them. And then the last part of it is about 2.35% of the data collection, 2.35%. So when we see this, mean and 1 standard deviation plus and minus, it should include 68% of the data collection. And when we move from minus 2 standard deviation to plus 2 standard deviation, this one here, it should include about 95% of the data collection, and with 3 standard deviation plus and minus will include 99.7% of data collection. So again, this is the same thing that we said. Mean, I can do it again. So we'll have mean plus 1 standard deviation, mean plus 2 standard deviation, mean plus 3 standard deviation, mean minus 1 standard deviation, mean plus minus 2 standard deviation, mean minus 3 standard deviation. And when you add up everything, you can say that it is added up at 3 standard deviation. Then you will have almost 100% or 99.7%, which is everything that you have, all the data collections that you have taken into the consideration. So the following bell curve with a standard deviation of 5 and a mean of 65 represent the age of grandparents of 20-2 plus. What percentage of grandparents are between the age of 60 and 70? So if the mean is 65, this one here, the mean is 65, and the standard deviation is 5, that means that at the second line, or the line on the right of your mean will be 65 plus 5, which is 70, and here we'll have 75, and here we'll have 80. And 1 minus or mean minus the standard deviation, on the left side we will have 60, 55, and 50. Now we are looking for 60 between 70, which means that is this area here. At what percentage? If we are asking what percentage, then each of them is 34%. 34%. So both of them, both sectors will be 34% times 2 equal to 68%. Data was collected about what age students learn to ride a bicycle, and the following data was collected. So when they are plotted into a bell curve, we see that the middle, the exact middle of the bell curve is at 8. That means that the mean is equal to 8. And then the increase that you see here is by 1. So 8, 9, 10, 11. That means that the standard deviation is equal to 1. And what percentage of students learn the bike between ages 7 to 10? So the sector that we are looking for now is this one here, from 7 to 10. So this sector here is 34%. This sector is 34%. And the third one is 13.5%. So when we are calculating the percentage, will be 34% plus 34% plus 13.5%. And when you use your calculator, you will have 68 plus 13.5 is 81.5% of students learn to bike between ages 7 to 10. And now let's see between ages 5 to 7. So now we are talking about this area here. So on this area, the first one here is 13.5%, and this area here is 2.35%. So when we talk about the ages or the percentage of students learn to bike between ages 5 to 6, then we will go 13.5% plus 2.5, 35%, which is in your calculator 15.85%. And now if we take a look again at the left one, now we are looking for between 10 to 11. So it is this area here. And this area here, the percentage is 2.35%. So the answer will be 2.35%. Please work on the questions on your textbook on pages 279 to 282, 1 to 4, and 6 to 9. I hope that you understand this, and I will see you on the next part of the lesson today.